Hi and welcome to CodeEdge. This is the first in a series of videos where we will be developing a web application using the Spring framework, particularly Spring Boot, Spring Data JPA, TimeLeaf Template Engine, Bootstrap UI, and we'll be securing this application with Spring Security and we'll be deploying it in Heroku Cloud. This is going to be a very hands-on tutorial, so buckle up. Before we start, I want to show you a glimpse of the final application that we will be building. This is a question bank application where if you log in as an admin, we can do basic CRUD operations like adding, editing, removing questions or categories. And we will be having a data table which lets us do search, paginate, sort, etc. And if you log in as a user, we will only be able to view and we will not be able to manipulate any info. We will also be exposing a public API to retrieve all questions or categories, which is meant to be consumed by other services. This Spring Boot application is secured using a form login and an OAuth login. The OAuth login uses Okta, an identity and access management provider, which provides us with a single sign-on feature. In this video, we will be building a simple demo application with a REST endpoint that returns a string and a UI endpoint which returns a basic HTML. We will also be deploying this to Heroku Cloud. For this, you need Java 8 and Maven 3 installed in your system. And you need to have an IDE of your choice. Spring is a Java-based framework for building enterprise application. It provides us with features like dependency injection or inversion of control, MVC framework, loose coupling, etc. It is essentially a framework of frameworks. It makes use of existing frameworks and builds on top of it to reduce the need for writing a lot of plumbing code. Spring Boot is a project built on top of the Spring framework. Spring Boot makes it easier to develop standalone production-grade applications. It auto-configures all the features you want to use, and you can start your application with a single click. We can generate a demo project from the Spring initializer site start.spring.io where we can add the Spring Web dependency and change the defaults according to our requirement and click generate. Or we can use the Spring CLI, which can be downloaded as a zip file, and the Spring bat file should be added to your environment class path. And this can be used as a command line tool. Once installed, open up your command prompt and type the command spring init and add the web dependency. And provide the name of the project you wish to generate. The project got generated and we can see the pom.xml which contains the dependencies for the project. As you can see, it contains the Spring Boot starter web dependency and the starter test dependency. We can check out the project structure. We have a demo application Java class generated with the Spring Boot application annotation, and it has a main method. I'll open the same project in IntelliJ IDE. Spring Boot application annotation is a combination of enable auto configuration, component scan, and configuration annotation. Spring Boot auto configuration attempts to automatically configure your Spring application based on the jar dependencies that you have added. For example, if HSQLDB is on your class path and you have not manually configured any database connection beans, then Spring Boot auto configures an in-memory database. When developing Spring Boot applications, you need to tell the Spring framework where to look for Spring components. Using component scan is one method of asking Spring to detect Spring managed components from predefined project packages. There are a couple of methods to run our application. One method is to build the jar using maven build command and run the jar from command line as java-jar. Or we can run the demo application directly from IntelliJ, like how we would run a simple Java class with main method. So we can just click on the play button in IntelliJ. The application has now started on 8080 port. Let's take a look at the localhost 8080 endpoint. This returns a 404 page not found error because we have not mapped any path in our application. So let's add a request mapping to the default path, and the dispatcher servlet will dispatch the HTTP request to this method. To do that, first we need to annotate our class as a controller and then add a method which returns a simple string response and annotate with the request mapping annotation and response body annotation. Response body is a Spring annotation which binds a method return value to the web response body. It is not interpreted as a view name. It uses HTTP message converters to convert the return value to HTTP response body based on the content type of the request. Let's run the application, and localhost 8080 returns the hello world string as the response. The boilerplate code that we generated from Spring CLI has used a default name for this application. So let's do some refactoring. We will rename this application class as Question Bank Application. And let's also rename the package name. For organizing the application better, let's create a separate controller instead of adding the main class as the controller. So let me create a new package named controller. And create a Java class named QuestionBankController inside that package. And annotate the same as a controller. Also, we will copy the request mapping method into this controller class. This mapping returns a string as a HTTP response body. Similarly, if we need to render a HTML view instead of a string, all we need to do is omit the response body annotation, and the method should return a view name to the dispatcher servlet. The dispatcher servlet will take help from the view resolver to pick up the defined view for the request. For this, we need the ThymeLeaf template engine dependency added to the pom.xml. By default, ThymeLeaf View Resolver looks into the templates folder under resources for HTML file. Since we return the view name as index, we need to create a index.html in the templates folder. Let's run this application. Open up the browser and in the /index path, the index.html is getting rendered. Next up, we need to deploy this application in Heroku Cloud. Heroku is a platform as a service that enables developers to build, run, and operate applications entirely in the cloud. When developing a web application, the natural progression is to take it online and make it available for end users. Since Heroku supports Java natively, it becomes a natural choice to deploy our Spring Boot application live. We need to create a free account with Heroku by signing up. The Heroku dashboard will look like this. You can create a new Heroku app from the dashboard itself, or we can use the Heroku CLI. Download and install the Heroku CLI. It is a command line tool, so we can open up the terminal which comes with the IntelliJ IDE and log in to Heroku using the Heroku login command. To deploy the code in our local system to Heroku, we need to create a Git repository and push it to Heroku remote. To initialize a local Git repo, type git init from your project's base folder and then add all the files from your project to this empty repository. Then make your first commit. Create a new Heroku app using the Heroku create command. This will create a Heroku app with an auto-generated name, and it also creates a remote Git repository with the name Heroku. You can rename your app to some other unique name if it is available using Heroku apps rename. All we need to do to deploy is git push our master branch to Heroku. Heroku automatically detects that this is a Java Spring Boot application and starts the build. And once the build completes, it deploys by running the generated jar file. We can check the logs to confirm if our application has started up in Heroku by typing Heroku logs --tail. As you can see, the application started up fine. Now to view our application, all we need to do is type Heroku open. It opens the browser with our live application. We can see the URL in the address bar and hello world is printing. Let's check out the /index path. It is also working as expected. In the Heroku dashboard, the new app is now visible. We can navigate and check the settings and configurations for our app here. Here we see the default command used to run the application after build. We can customize this by adding a proc file in our project. Right now we don't have any add-ons. In the deploy section, we can change our deployment method to suit our needs. We'll be using the default Heroku CLI method. In the settings page, we can check the Heroku Git URL. And if we have a custom domain, we can provide that. So we can use our own domain instead of the Heroku auto-generated subdomain. That's it for this video. In the next video, we will see how to add PostgreSDB to our application and do CRUD operations using Spring Data JPA. GitHub link for this project is provided in the description below. You can check out each lesson by choosing the appropriate branch name. Thanks for watching, and we'll see you in the next video.